So number 1 says the Earth's diameter is approximately 7,980 miles. The moon's diameter is approximately 1,995 miles. About how many times as great is the volume of the Earth as the volume of the moon? Now, I could find the volume of both and figure it out that way, but I don't want to do that. Okay, those are ginormous numbers. So instead, it's not asking me what the volumes are. It's asking me about how many times is great. So is the volume of the Earth as to the volume of the moon. And what I've been given is the diameter. So if I make a ratio of the diameters, okay, which could also be the ratio of any side length, the ratio of the perimeters, anything that just has the just units and not squared or anything, is 7,980 over 1995. Okay, so that reduces down to 4 over 1. Which means that the diameters, what I do here is I would multiply by 4. So the diameter of the moon, the diameter of the Earth is about 4 times the diameter of the moon. The areas, that would be times 4 squared, which is times 16, right? So the surface area of the Earth is about 16 times bigger than the surface area of the moon. And then the volumes, which is what it's really asking me for, is going to be times 4 to the third, which is what? 64. So times 64. So the answer then, which I guess I'll write right here. I know I didn't give you tons of room. About 64 times greater. Okay. Everybody okay with that? Does that make sense? I don't have, now I could find the volumes and then I could find that ratio and it would divide out to be 64 instead of dividing out to be 4, but that's a whole lot better, especially if you don't have a calculator in your hand. Okay, we're good? Okay. So then on these, I'm betting I probably didn't give you enough room at all for any of this, but I was trying to save some paper. So we're going to find the surface area and the volume of each figure. So to start with the surface area of this one, my surface area plan, right, I could find just the lateral area of the cylinder. Do you agree with that? Okay, so if I start with the lateral area of the cylinder, and I would need to add a circle, how many? 1 to get the bottom on there, plus I've got to find the surface area of the sphere, but I only want how much of it? Half. I would caution you against putting hemisphere there because it is a hemisphere and it is the surface area of a hemisphere. However, a lot of people that did that, I noticed, didn't actually go back and take half of it because you didn't see the 1/2 there. And even though you knew what to do, I think just some people weren't doing it. Now, you may have done it just fine. Just be careful with that, okay? Now, when I do that, do I need to subtract a circle? No, because when you take that sphere and you cut it in half, remember, it's empty. So what you get is like a bowl. There isn't a circle there. So there isn't one there to subtract. Does that make sense to you? If I had done the surface area of the cylinder, then I would need to do that, but I don't need to do that. So my lateral area of the cylinder then, so lateral area of the cylinder, you may need a separate sheet of paper, I probably do too, 2 pi RH. So this is going to give me 2 times pi times the radius, which is what? 6 times the height, which is 9. Okay, so 6 times 9 is 54, times 2 is 108. So lateral area of the cylinder is 108 pi. There we go. So then I need to find the area of the circle, and that is pi r squared, so that is 36 pi. In the interest of space, I'm just going to put the answer there. Then for the sphere, so the surface area of the sphere, that is 4 pi r squared. It's going to give me 4 times pi times 6 squared. So that's 36 times 4, which is what? 144. 144 pi. Okay. So here's what I'm going to have to do, I think. I don't have much room for volume. I might be able to cram all the volume in here. You just may not be able to read it. to get my final answer here, then I need to work this out. So I get lateral area of the cylinder plus, oh, I don't know why I'm rewriting that. I need to actually write that down. So the lateral area of the cylinder is 108 pi plus the circle, which is 36 pi, plus half of the 144 pi. So I can go ahead and add these in pieces. 108 plus 36 is going to be 144 pi, plus half of that 144 is going to be 72 pi. So my total surface area then is what? 216 pi, and that would be inches squared. So I tell you what, let's go ahead, let's go through. I'm going to do surface area on all three of these, and then I'll do volume on another section of it, like on a blank page or something. So let's go ahead and do surface area of the next one, and then I'll figure out how to make all this fit. And so here, find the surface area of this. I would need what part of the cone? Lateral area, surface area, or what? Lateral area. Okay, so I'm going to take the lateral area of the cone. I can add to that the lateral area of the cylinder plus half the surface area of the sphere. Because there is no such thing as a lateral area, right? Now, I could do this differently. I could have found the surface area of everything and then taken off what I didn't need. So there are definitely different ways to do your plan, but that is one way to do that. Now, in order to find the lateral area of the cone, the lateral area formula for that cone is just pi RL. So pi, the radius is 4. What is L? 5, and it is a slant height, and they gave it to me. So the lateral area of the cone is 20 pi. All right, so then I need the lateral area of the cylinder. That is 2 pi RH. It's 2 times pi times 4 times 7. So 4 times 7 is 28, times 2 is 56. So lateral area of the cylinder is 56 pi. Then surface area of the sphere is 4 pi r squared. It's 4 times pi times 4 squared. 16 times 4 is 64 pi. Okay, so there are all my pieces. Then I go back and make sure you actually follow your own plan, because I've seen weird things happen there too. Lateral area of the cone is 20 pi, plus the lateral area of the cylinder is 56 pi. Don't worry, on the test you'll have a lot more room to write. Plus half of that 64 pi. So that 20 and the 56 gives me 76 pi plus 32 pi. So the total surface area is 108 pi centimeters squared. Everybody okay with that? All right, do I need a plan for the last one? No, this is just a sphere, so my surface area formula is 4 pi r squared. That's 4 times pi times what squared? 6 squared. And so 36 times 4 is 144. 144 pi centimeters squared. And since we have room on this one, we'll go ahead and do the volume here. We don't have to go back and do the volume. I'm going to have to write them somewhere else. But we'll do the volume of the sphere. Volume of the sphere is 4/3 pi r cubed, right? So this gives me 4/3 times pi times 6 cubed, 216, good. So 4/3 pi times 216, 288, good. Because the easiest way to do this here is to go ahead and divide that by 3 and then multiply by 4. So you get volume is equal to 288 pi centimeters cubed. Everybody okay with all that? All right, so I don't know if you have room on your paper. I'm guessing you probably don't for the volume of those three. you could do it on a separate sheet of paper. Or I tell you what, this is what I'm going to do. I'm going to go through and I'm going to finish the rest of them, and I'm going to do the volume of these two at the very end. That way we can just get through some of the rest of them. Let's do that. I just have to remember to come back and do that, which I may not remember to do that. All right, so now we're just finding the volume of the rest of this stuff, no more surface area. Volume here, this is a prism, so it is big B times H. Right? The shape of the base is a hexagon, so big B is 1/2 apothem times perimeter. My perimeter is going to have to be N times S. N is 6 times 8, so my perimeter is 48. My apothem, I'm going to draw that in. This is a hexagon, so I know I get a little 30, 60, 90 triangle here. This whole thing is 8, so this is 4. So the height of that little triangle is 4 square root of 3. So I have all those pieces. Then I get that big B is equal to 1/2 times 4 square root of 3 times 48. So half of 4 is 2 times 48, 96 square root of 3. Come back over here, get 96 square root of 3 times 11. Okay, so 96 times 10 is 960. 96 times 1 is 96, right? 6, 5, 10, right? So volume is 1056 square root of 3 feet cubed. Everybody good with that? All right, on 11, I could use big B times H. That's fine, but it is a cylinder, so I can use pi r squared H. So what's the radius here? 21 over 2. Good. 21 over 2, right, which means that we got to keep it like that. So this is equal to pi times 21 over 2 squared times 30. All right, so 21 over 2, is that really that difficult to square? No. Should you already know what 21 squared is? Yes, you should. What is it? 441. Okay? Notice what happens there, because you should know that, just like she did. Just like a genius over here. But guess what? Yeah, 21 squared is 441. 12 squared is 144. Let that soak in for just a minute. You should never forget what 21 squared is. Okay? Does that work with every single number? No, it doesn't. But it works with 12 and 21. Okay? So there you go. Work smarter, not harder. Let me erase that so it's not in the way. Come on. All right, so that's good. You should know it's a little bit more than 400, right? So that should, because you should know 20 squared. All right, so when you square this, though, oops, you've got pi times, this is 441 over, what's the denominator? 4 times 30 over 1. Can you reduce before you multiply? You actually can, but it may be easier for you if you didn't. I mean, that's up to you how you want to think about how you want to do it. I can reduce the 30 and the 4 to make it 15 and 2, but then I'm multiplying 15 times 441 instead of 30, so you might feel like it's easier to multiply the 30 and then take half of it. You know, it's just kind of whatever. So you want to think about those things, you know, before you do them. I would say maybe multiplying times 30 would be a little bit easier instead of the multiplying by 15. So let's just think about what that would look like. So 30 times 441. All right, well, I know if I just do it by 3, I can add a 0 on the end. So 3 times 400 is what? 1200. 3 times 40 is 120. 3 times 1 is 3. Okay, so then that gives me 3, 2, 3, 1, and I got to put a 0 on the end. Yes? Okay, I mean, that's the same as just multiply. You can multiply however you want, but that's just a... and then what do I need to, then that's over, I get that over 4, right? So I can reduce that. I know that's an even number. I know right now it's not going to divide evenly by 4 because right here I couldn't have divided it evenly by 4. Does that make sense to you? I just decided to leave it as 30. So I know I really just have to take this and get half of it. And then, so if I take half of this, it's going to give me what? 6615 over 2. Good. And then, do I stick pi on the end? Where does pi go? On top. Inches cubed. That's kind of a yucky one, but it's doable for sure. All right, so 12 is composite, so we need a plan, right? Volume plans are a lot easier than others. So my plan is to find the volume of the cylinder, good, minus the volume of the cone, right? Does that make sense to you? All right, so we'll start with volume of the cylinder. That is pi r squared h, so that's pi times 8 squared times 12. 64 times 12. Okay, my human calculator over there today. Oh. Hey, why'd you tell him that? You should have told him that. They're like, man, she's on it today. That's good. All right, volume of the cone, right? That is 1/3 pi r squared h. So that's 1/3 times pi times 8 squared times 12. So it's all the same, right? So it's really just 768 divided by 3. Now, is 768 going to divide evenly by 3? Yes. Okay, because 7 plus 8 is 15 plus 6 is 21. So since 21 is divisible by 3, 768 is, and your volume of your cone then is what? 256 pi. Okay. So then I just take the 768 pi minus 256 pi. 512 pi. That's okay. Y'all, I know y'all can come up with those. She's just going to help us get through it. You can do the math. Yeah. All right. Are we all good? Okay. So do I need a plan on this next one? No. Volume is 1/3 pi r squared h. Now, they've given me the height. Did they give me the radius? No, but they gave us the circumference. Circumference is 2 pi r, and they give us 16 pi equals 2 pi r. So what does the radius equal? 8. Because you divide by 2. You don't take the square root because it's not area. The radius is 8. So this gives me 1/3 pi times 8 squared times the height, which is 15. All right, so I can take 1/3 of 15 at this point, right? So I can get 8 squared is 64 times 5, and then pi. So your volume in the end is going to be what? 320 pi. Syntax. Do you know where you went wrong, though? Did you find that? Oh, okay. Oh, I gotcha. Okay. All right. Don't need a plan here either. Volume is 4/3 pi r cubed. Right? So 4/3 times pi times 5 cubed. Okay, so before we even go any farther, is this going to divide out evenly? No. If this isn't divisible by 3 at all, then it's not going to. 5 cubed is what? 125. Because it's 5 times 5, which is 25, and if you have 5 quarters, that's 125. So you get 4 times 125 pi over 3. So 4 times 125 is 500. So you get 500 pi over 3. Notice, all in one fraction. It is not 500 over 3 times pi. Yards cubed. All right, so I'm just trying to... I know your reviews are never ideal as far as spacing is concerned, but I'm trying not to kill a bunch of trees, but give you problems to practice. All right, so my volume plan would just be volume plus volume, right? Volume of prism plus volume of pyramid. So what do I need for the volume of the pyramid that I don't have? the actual height. I have the slant height. I do not have the height, right? So to make the height in here, I get this triangle that comes like this, right? I need the height. This part right here is what? 3. So is this a 3, 4, 5 triangle? No. Right, because 4 is the hypotenuse. You got to be really, really careful. So 3 squared plus h squared equals 4 squared. So this is 9 plus h squared equals 16. So h squared equals what? 7. So h is the square root of 7. Okay, so be careful with that whole 3, 4, 5 thing. That's why I threw one of those in there, because it's real easy to assume that it's one thing when it's not. All right, so now I can find the volume of the prism. So the volume of the prism is just, is big B times h. So big B is base times height, or base or side squared, whatever you want to think about that. So big B is just 36, right? You have a question? That's okay. Ask me. You look confused. Where I'll lose you. Oh, yeah, because I didn't do it yet. Yeah, okay. Sorry. I was finding what I needed, but then I started with prism. Okay, I'm sorry. I jumped around there. I was just trying to make sure I had everything I needed before I started, but then I started first with that. So this is big B, which is 36 times 6 is 216, because that's basically 6 squared. Is it 216 pi? No. Don't just go throwing pies on everything. I see that a lot too. Oh, I forgot to stick my pie on the end. No. All right. Volume of the pyramid is 1/3 big B times h. Was it the same big B? Yes. And the height obviously is different though. So this is 1/3 times 36 times the square root of 7. Okay, so I can take 1/3 of 36. What is that? 12. So it's 12 square root of 7. I have the pieces that I need. Oh, that's the volume of the pyramid. So pyramid and prism, then I just add them together. So it's 216 plus 12 square root of 7. I cannot combine those. There are still some people that try and combine. Please don't do that. And that is meters cubed. There's your volume. Okay, everybody good? Yes? All righty. Volume here. Volume is big B times h. Big B is base times height. What's the base and the height of the base? 15 times 9. B is 135. So I could do 15 times 10, which is 150, but then I take a 15 away, and that's how I get 135, right? So this gives me 135 times 12. What is it? 1,620. Y'all agree with that? I check her just in case. How are you supposed to know? She doesn't even give you time to think, does she? All right. So 10 times 135 is 1,350, right? And then 2 times 135 would be 270. Okay. So is that 1,620? Yes, 1,620. Yes, so she was right. All right. Volume here. This is a cone, 1/3 pi r squared h. Do I have everything that I need? I need the height, right? And so this is 7. This is my height. This is 25. So h squared plus 7 squared equals 25 squared. H squared plus 49. 25 squared, you should know, 625. Good. And then h squared is equal to 576. Because look, you can subtract 50. That's easy, right? And then you just have to add 1 back. And then that you should know as well. 24. That's why you need to know your perfect squares so you don't get stuck on that. Otherwise, could you do the tree here? Yes, but the tree is going to take you a while, and you don't need to spend time on that. So 1/3, plus this is a Pythagorean triple. I wouldn't expect most of you to notice it, but it is 1. 1/3 times pi times 7 squared times the height, which is 24. All right, so I can take 1/3 of the 24. That gives me 8. 7 squared is 49. Oh, that's 7. 49 times pi. 392. Because you can do 8 times 50, right? Okay, and that would give you what? What's 8 times 50? 400. Okay, but you didn't want 50 of them. You only wanted 49 of them. So that 400 minus 8, that's where you get the 392 from. Bless you. 392 pi meters cubed. All right, so volume, 1/3 big B times H. Big B is a square, so we can use base times height or side squared. 18 squared is something that you should know. 324. And remember, once you have actually practiced these and you have them in your head, you know that 8 squared is 64, so this has to end in a 4. So you can kind of narrow it down, like if you got, like I don't remember if it was 576 or 324, whatever. You know it has to end in a 4, so your big B is 324. That is something you should be able to come up with pretty quickly. And then this gives me 1/3 times 324. I have the height, that's 20. Now, is 324 divisible by 3? Yes, because 18 was from the get-go, so I know that this has to be. So when I do this, what's 1/3 of 324? 108. And be very careful with that. Ooh. Be very careful with that, so that you're not trying to put something like 18 or something ridiculous, because that happens, right? Or 28. So 108 times 20 then? 2160. Good. 2160. Okay. 60. Oh, dang it. What am I doing? 2160. Yeah, that makes way more sense. Pi? No. Thank you. All right. We good? All right. So I am going to go back. Actually, I think I'm going to, well, no, I'll go ahead and do the this side, and then I am going to go back and do the volume on the other ones. But all right, so transformations. A transformation that does not change the size or shape of a figure is what? Isometry. Okay. All right, so then it says reflect the figure with the given vertices across the given line. We have to write the ordered pairs for the new vertices and the mapping. Plus, we have to graph all of this stuff. So I'm going to plot the points. E is at -3, 2. F is at 0, 2. G is at -2, 5. Okay, and then you connect with a straight edge. And I'm reflecting in the x-axis. So I'm going to draw in the x-axis. I know you know the difference, so make sure you don't do something ridiculous and use the wrong one. Now, do you have to actually reflect it on the graph to get your answer? No. I mean, you have to end up with both, but you can start by just coming up with your answers. I'm going to need E prime, F prime, and G prime. And if I'm reflecting in the x-axis, my x value stays the same, so -3, 0, -2, and the sign changes on my y. So this becomes -2, -2, and -5. So then you can plot them one of two ways. You can do it, I mean, you're going to have to you have to count on the graph anyway to plot points, but I could just ignore that and know that I'm 2 away. I come 2 away over here. That's E prime. Same thing for F. Same thing for G. And then you can double check yourself against those. Oh, that pen is not right. There we go. And then it says that I also need to write this in the mapping. So x, y maps to what? X negative y. Good. So that's your general rule there. Alrighty. So next one, we'll plot these points. 2, -2, 4, -2. That's P. That's Q. R is 3, -4. And we are reflecting in the line y equals x, which is easy to draw, not difficult, right? So we should not be messing that up for sure. Get that drawn in. Now, I showed you how to count with this, but that was kind of yucky, right? Nobody wants to have to count with that. So, yeah, so I would just find these first, because I think the counting, some of you may not do it right anyway. Plus, that's the whole point, is that we can figure out how to do this without counting. When you reflect in the line y equals x, well, y equals x, so x equals y, so what happens here? Good, they just switch places. So that's my mapping. xy just maps to yx. So I just take these. P prime is -2, 2. Q prime is -2, 4. R prime is -4, 3. Then I can go and just graph them, and I don't have to worry about counting anything anywhere. So -2, 2 is P prime. -2, 4 is Q prime. -4, 3 is R prime. And there we go. Okay. Everybody good? All right. So, number 5 says, quadrilateral JLKM has vertices of these points. If the figure is reflected across the line y equals x, what is the coordinate of M prime? So, we don't want to have to go and plot the, I mean, you can, but I only have to know M, or M prime rather. And I know since I'm reflecting in y equals x, then xy maps to -y, not negative y, I'm sorry, just yx. Sorry, got carried away there. It's just yx. All right, so M prime then, -3, 5. You just switch them. You don't have to plot anything. It's just understanding the rule, and it's that easy. And I think we can do number 6 before the bell rings. ABC has these vertices. If the figure is reflected across the x-axis, that means that xy maps to x -y. So I can just write those down. A prime is 2, -1. B prime 6, -1. And C prime is 4, -3. Okay, everybody good? Okay. So once the bell rings and y'all leave, I am going to finish this up. I will finish this side, and then I will go and do the, I'll do the volumes on the other ones. Okay. All right, so I'm going to finish this up. So we're going to translate the figure with the given vertices along the given vector, write the ordered pairs for the new vertices, and the mapping. All right, so I'm going to plot my points. Go to 1, -1. That's R. 1, -3. That's S. 4, -3. T. U is 4, -1. And I think I'm going to move my R. Right, so then I'm going to connect my dots here. So I am going to translate it along the vector -5, 2. So start here. Actually, there's not a point there. I'm going to draw in a vector. I start here, go -5 and up 2. My vector would look like this, because remember I can draw the vector anywhere on the graph, but every point's going to move that distance in that direction. I'm going to need R prime, S prime, T prime, U prime. My mapping, XY, maps 2. So my vector is -5, 2, so that means it's going to be x -5, y plus 2. So I can find all my points before I do that, or I can count, or I can just do both. So to get R prime, I'm going to go left 5 and up 2. That's R prime. S, I'm going to go left 5 and up 2. That's S prime. Go left 5 and up 2. T prime. Left 5 and up 2. U prime. Okay, then connect my dots there. So there are my ordered pairs. I can get the points off of my graph, or I can just go ahead and do this mapping. So for r, if I do 1 minus 5, that's negative 4. Negative 1 plus 2 is 1. That's where I am, is a negative 4, 1. S would be negative 4, negative 1. T prime would be negative 1, negative 1. U prime would be negative 1, 1. All right, so here, D is at 3, 1. E is at 2, negative 2. F is at 3, negative 4. G is at 4, negative 2. Alrighty, so I draw in my vector. Start here. I'm going to go negative 6, 2. So it's going to look like that. I'm going to need D prime, E prime, F prime, G prime. My mapping xy maps to x minus 6, y plus 2. So I can go ahead and get my points along here. So 3 minus 6 is a negative 3. 1 plus 2 is 3. So then for E, it's going to be negative 4, 0. F is going to give me negative 3, negative 2. G is going to give me negative 2, 0. So then when I come over here and plot my points here, I'm going to go to the left 6 and up 2. That's E prime. D prime, left 6 and up 2. G prime to the left 6 and up 2. F prime to the left 6 and up 2. Then I connect my dots. And I'm done. And you can double check your points with what you have on here. All right, so then in a quilt, a polygon with these vertices is translated repeatedly along this vector. What are the coordinates of the third polygon in the pattern? Okay, so it means I start with a polygon, the third one in the pattern. So I start here, and then I translate it along these. So let's say that it's my prime. I should have labeled these with letters to help. But if I'm going to change it along this vector, then my first set would be 7, 3, 11, 4, 13, 0, and 9, negative 1. So then if I do it again, that's what's called double prime, and that would be my third one. So it's doing this twice, or doing this one again since it's already done once. So that would give me 11, 8, 15, 9, 17, 5, and 13, 4. So then the next one says, what are the coordinates of the following reflections? So I'm going to reflect it in the x-axis. So remember, xy maps to, and since I'm reflecting in the x-axis, the x value stays the same, y value changes. So this is not what it's asking you for, but that's what's happening. So to get this point here, x value stays the same, sign changes on y. There's your answer for A. If I'm reflecting in the y-axis, then xy maps to negative xy, because y stays the same. So you get 3, negative 7. That's what we have there. Reflected in y equals x, then xy maps to yx. So x and y just change places, and you get negative 6, negative 3. All right, so now I'm going to go back, and those first three that I did not do the volume on because I didn't have room, I'm going to do them now. I have a blank one I can use. Okay, so now I've already done the surface area. Now I'm going to do volume. So here my volume plans are a lot easier. So I just want the volume of the cylinder plus the volume of half. Well, I actually want half the volume of the sphere. It would be better to write. I only want half the volume of the sphere. So volume of the cylinder is equal to pi r squared h. So that's pi times 6 squared times 9. That's going to give me pi times 36 times 9. So I can do 36 times 10 is 360. And then I didn't want 10 of them, I only wanted 9 of them, so I can subtract them. So 360 minus 36. Well, 360 minus 30 is 330. Minus 6 would be 324. So the volume of the cylinder is 324 pi. All right, so then I need to find the volume of the sphere, and that is 4/3 pi r cubed. So that's 4/3 pi times 6 cubed. So 4/3 times pi times 216. So I can take 216 and divide that by 3. That's going to give me 72. So this is really 4 times 72 times pi. So I can double that and double it again, and I get 288. So the volume of the sphere is 288 pi. Then I need to go back. I have my two pieces and do my plan. So this is 324 pi plus half of the sphere, which is 288 pi. So it's really 324 plus 144. It's going to be 468. So your volume is 468 pi inches cubed. Okay, so there's volume number 1. I already did the volume of that one, so I just need to do this one here. So volume here, I want the volume of the cone plus the volume of the cylinder plus half the volume of the sphere. All right, so the volume of the cone equals 1/3 pi r squared h. Well, I don't have the height, but if I draw in the height, there's the height. The radius is 4. This is 5. This is a 3, 4, 5 triangle, so the height is 3. So I get 1/3 times pi times r, which is 4 squared, times the height, which is 3. So 33 is 1. So the volume of my cone is just 16 pi. Then I'm going to do the volume of the cylinder. It's pi r squared h. Pi times 4 squared times the height, which is 7. So that's going to give me pi times 16 times 7. And so 16 times 7 is 7 times 10 is 70. 7 times 6 is 42. You add the two together and you get 112 pi. So then I need the volume of the sphere. That is 4/3 pi r cubed. So that gives me 4/3 pi times 4 cubed. All right, so I can already tell you that I'm not going to be able to divide this evenly because 3 doesn't go into 4. But 4 cubed, that's 4 times 4 is 16, times 4 is 64. So this is going to give me 4/3 pi times 64. So I can't divide that out, so I need to take 64 and divide it, and multiply it by 4, rather. So the volume of my sphere is 256 pi over 3. So now, since I already did this one, we're going to pretend like this isn't here. Just ignore that. So I have room to work. I'm going to come up here and do my plan. So my plan is to take the cone, which is 16 pi, add to it the cylinder, which is 112 pi, plus half the sphere, which is 256 pi over 3. So I can reduce this here. So this is going to give me, let me go ahead and add these two together. So 16 and 112 is going to give me 128 pi plus half of 256 is 128 plus 128 pi over 3. I just reduced that. I mean, I could multiply and get 6, then I can reduce it. Well, that's not going to divide evenly, so I need to get a common denominator here so that I can actually add these, and this is going to give me 384 pi over 3 plus 128 pi over 3. And so that's going to give me total volume as 512 pi over 3. All in one fraction. The pi is not hanging out on the side. I cannot reduce that because I couldn't reduce it up here. That is it, centimeters cubed. All right. So there is everything on your review. Plus, you can expect some solids of revolution, which means you might have to graph something and then revolve it and find surface area and or volume. So be prepared for that. I didn't put any of these on here because we had just done that.